Hi, welcome to Physics Teacher, the channel that prepares you for the Waterloo Math and Science Contest. This is a grade 12 physics Sir Isaac Newton contest question. And what we have is an incline with one block having a mass of 15 kilograms and a coefficient of kinetic friction of 0.5. It's attached to the axle of one pulley. And then we have two fixed pulleys here and one rope. This rope is attached here, goes around this movable pulley, up around the fixed pulley, down around this movable pulley to this fixed pulley and back to the axle. And then on the other side here, we have a hanging mass of 30 kilograms. And the question says, what is this vertical acceleration of this mass? Give it a try, and I'll be right back with the solution. Alright, so let's start by drawing forces on this diagram. So we have free body diagrams. We have this 30 kilogram one, so we're going to have gravity acting down on that. Gravity is mg, or just m being 30, so it's going to be 30 g's. And then we have tension holding it up. Now the tension is being provided by two ropes, so we have two tensions here. Let's call them both T, since they're all the same rope. Now for this mass here, it is going to have a kinetic friction parallel to the incline. So here we have Fk. We have a force of gravity acting vertically down, which we can split into components right here and here. So the component along the incline would be 15, so mg, so 15g. Times our angle is here, that's 53.1, so it'd be times the sine. I'm just going to call that theta, 53.1. Let's say 53.1 is theta. And then this portion here, that component would be 15g cos theta. And then what we have is three supporting ropes right there. So we have three tensions right there. And finally, we have a normal force perpendicular to that surface in contact. We'll call that Fn. Alright, so let's apply Newton's second law. We'll start with the 15 kilogram mass. 15 kilogram mass. And we'll choose our coordinate system. So this will be our positive direction here. We'll have that as positive x, and positive y will be in this direction. And let's apply Newton's second law. So if we apply Newton's second law for all of our y components, well, there's no acceleration in y, so that's an equilibrium. So all those forces are going to sum to 0. Alright, so in our y component, we have the normal force, that's our positive component. And then we're going to subtract this here, this y component of gravity, which is 15g cos theta. So you have 15g. And if you actually type in the cos of 53.1 in your calculator, you get exactly 0.6. So that's 3/5. And that will equal 0. So if we rearrange, we can solve for the normal force to be 9 Gs. Alright, well, let's do the same thing, but in our x components. Let's look at all the forces acting in x, and that'll equal mass times acceleration. Let's call this acceleration 1 for block 1, and I'll get to that y a little bit later. Alright, so all the forces acting in x, well, we have three tensions, so three tensions. And then minus, we have this component of gravity, which is 15g, and the sine of 53.1 is actually 4/5, so 4/5. And then we have minus our kinetic friction, which is mu times Fn, where we know Fn is 9g. And that'll equal mass times that acceleration. Alright, simplifying this a little bit, we get 3t minus, this here would be 12 g's, and if you sub in mu as 0.5, that's 4.5. So 12 minus 4.5 is minus 16.5 g's. And that'll equal our mass, which is 15, times that acceleration number 1. All right, let's go ahead and look at our 30 kilogram mass. So our components then is down is going to be our positive x direction because our pulleys is rotating, essentially rotating our coordinate system there. So down is going to be positive x. And so if we analyze all the forces then in x, that's going to equal this mass, I'll just call it 30, times its accelerations, let's call this block 2. So this will be A2. Alright, so all of our forces is we have 30g, so we have 30 g's acting down. That's our force of gravity. Subtract 2 t's. And this t will equal this t from our 15 kilogram mass because it's all the same rope. And all of these pulleys are frictionless. And so that'll equal 30 A2. Alright, so now I want to look at A1 and A2. Are they the same? They're actually not. In a lot of these questions where you just have one rope going over one pulley, yes, they are. But let's analyze this a little bit deeper. Let's say that this 30 kilogram mass goes down by 1 centimeter. If it goes down by 1 centimeter, both of these ropes need to each go down by 1 centimeter. Now, since each of these ropes go down by 1 centimeter, it means that this rope on this side of the pulley needs to lengthen by 2 centimeters. And those 2 centimeters need to come from this right side of the rope over here. Now, this rope is supported by 3 supporting sections. So that means that each rope needs to shorten by 2/3 of a centimeter each in order to allow this rope on the left side to lengthen a total of 2 centimeters. Now, if these each shorten by 2 centimeters, that means that this first block here on the right side, the 15 kilogram block, only moves 2/3 of a centimeter. So, while block 1 only moves 2/3 of a centimeter, block 2 moves 1 centimeter. This means that block 1's speed and acceleration will also be less than the second block. So A1 and A2 are not the same. In fact, we can label A1 to be exactly 2/3 A2. So that leaves us with 2 equations. Here we have equation 1. I'll rewrite it here. So we have 3t minus 16.5g, which equals 15. And instead of A1, I'm going to write 2/3 A2. And this is our second equation here. So now we're left with 2 equations with 2 unknowns, tension and acceleration. So we can rearrange and solve for acceleration. Alright, so rewriting the question up at top to give myself a little room here, what I'm going to do is I'm going to take equation 1 and multiply it by 2, and then I'll take equation 2 and multiply it by 3. So doing that is going to give me 6t minus 33g, which is going to equal, now on its own, here we have 15 times 2, which is 30, divided by 3, which is 10, and then times by 2, that's going to give us 20a. And this a is A2, it's the acceleration for the second block. And then multiplying equation 2 by 3, we get negative 6t plus 90g is going to equal 90a. So now if I add the 2 equations, the t's will cancel, and we get 57. G's equal 110a. Dividing both sides by 110, we get a equals to 57 divided by 110 times g, which is 9.8 meters per second squared, or an acceleration of 5.08 meters per second squared. Our answer is E.